welcome to the first in a two-part set of tutorials on simultaneous equations. This is a topic that I actually think students generally find quite fun because it's not too difficult and you get to really solve a problem that looks too hard to solve. So you get a lot for a little, which is always a nice thing in any subject, but particularly in maths. So there are a number of ways actually to solve simultaneous equations. I'm going to show you a method that I know is popular in schools in Scotland. I think it's quite a good method. It's different to the one that I was taught years ago, but actually I think it's probably better. So I'm going to teach the modern method. And what better way to do it than through an example? And often the questions that you're given for simultaneous equations are sort of real world problems, as it were. So where I live, which is quite rural, it's springtime at the moment, and all around me there is a lot of ploughing and sowing going on in the fields, and so I thought I would use an example to do with a farmer who is sowing some crops. So the problem that we have to solve, so this is an example, and the problem we have to solve is the following. The farmer sows 4 fields of barley, which is a very popular crop around here, and he sows 3 fields of potatoes. And it takes him 20 hours of tractor time to do that. On a different day, farmer sows 2 fields of barley, and 5 fields of potatoes. And that takes 17 hours. So this is the standard way that these types of problems are sort of set up, is that you sort of have 2 scenarios with different outcomes and different inputs, and you have to work out the inputs. And that is the whole point of solving simultaneous equations. So scenario 1, we're told that if there are 4 fields of barley being sown and 3 fields of potatoes, that takes 20 hours. The second scenario, if 2 fields of barley are sown and 5 fields of potatoes, that takes 17 hours. And our job as young mathematicians, well, in your case young, most likely, although I might have some people following along who are a little bit more mature in years, certainly that's true for me, sadly. But our job as mathematicians is to work out how long does it take to sow 1 field of barley and how long does it take to sow 1 field of potatoes. And if you know that, then you can work out how long it will take to sow any combination of fields of barley and potatoes. So it's very powerful information to have. So let's set up some variables. And we don't have to use x and y, we can be a bit more inventive. Let's say that b is the number of hours to sow 1 field of barley, and let's say that p is the number of hours to sow 1 field of potatoes. And I've just chosen variables that make sense, you know. So B stands for barley, P stands for potatoes, and this symbol literally means how many hours it takes to sow a field of barley, and P is how many hours it takes to sow a field of potatoes. And then we can convert the two scenarios into equations, and it's nice to see a real-world problem being transformed into a maths problem. So the first scenario says that 4 fields of barley, okay, so that's 4 lots of B, plus 3 fields of potatoes, so 3 lots of B, takes 20 hours. And remembering that our B and P stands for number of hours, 4 lots of B plus 3 lots of... Oh, look at that. Look, I'm sorry. I can be such a ditz sometimes. 4 lots of B plus 3 lots of P equals 20. 4 barley, 3 potatoes. Second scenario, 2 fields of barley, 2 lots of B, plus 5 fields of potatoes, 5 lots of P, 17 hours. And this now becomes a maths problem. It is a set of 2 simultaneous equations, and they're called simultaneous because you have 2 unknowns, B and P, and you are simultaneously given 2 equations for those 2 variables, and you have to solve these 2 equations for the 2 variables. Just as a rule of thumb in maths, if you have a number of variables that you need to solve for, and you wouldn't be doing this at this level of maths, but it's good to know just generally, you need to have the same number of equations as unknowns in order to solve for those unknowns. Generally, it's not always the case, but as a general rule of thumb. So if you have 4 unknowns, generally you'll need 4 equations, or in other words, 4 sort of pieces of independent information that you can then use to find out those 4 unknown things. And there are methods in maths. There's a huge field called linear algebra, which is a set of methods to solve those more complex problems. Here, at this level of maths, we just have 2 pieces of information. We're given 2 inputs. So we have 2 sets of information, and we have 2 unknowns that we're trying to solve for. So now, scenario to one side, we have to do some maths and solve these equations. And a nice method is the following. You sort of see, is there a way that I can multiply one of these equations so that one of the terms in each equation looks the same? And let me just show you by an example. If I multiply the second equation by 2, I can make it look like the first equation in terms of that first term, because this 2b will turn into 4b. And that will allow me to make a big simplification. So let's just do that. Let's multiply that second equation by 2. So let me actually number these equations. Let me call this equation 1 and equation 2, and I'm going to multiply equation 2 by 2. And I therefore get 4b plus, and when you multiply an equation, you have to multiply every term by the same factor. So 2 times 2b is 4b, plus 2 times 5p is 10p, and then equals 2 times 17 is 34. Now, if I write equation 1 underneath that, this looks a lot friendlier now, because what I can do is actually subtract every term in this equation from the one above. So I'm going to subtract 4b from 4b is 0. And that was why I chose to multiply by 2, because I wanted to get 2 of the terms, as it were, to look the same. And in that way, when I either add or take away these equations, I can get a 0. So 4b take away 4b is 0. 10p take away 3p is 7p. And 34 take away 20 is 14. I've chosen the numbers to work out nicely here. So we have now an equation 7p equals 14. And so straight away we see then that p is 14 divided by 7. We have a common factor of 7. P is just 2. So we already have solved for one piece of the information. It takes 2 hours to sow a field of potatoes. And to find b, we can go back and choose either of our original equations. Let me just choose, say, that first one. I have that 4 lots of b plus 3 lots of p, but we know now that p is 2, is equal to 20, i.e. 4b plus 6 equals 20. Taking 6 from both sides, I get that 4b is equal to 14. And so b is 14 divided by 4, which is 7 over 2, which I can write in this case, because we're dealing with something familiar like hours, write that as 3.5. So I have then, that b is 3.5 hours. And we've solved the problem. It takes 2 hours to sow a field of potatoes, and it takes 3.5 hours to sow a field of barley. And if the farmer now, say, on the next day wanted to sow, let's say, 3 fields of barley and 3 fields of potatoes, he would be able to use these answers to work out exactly how long that would take. A very important thing with these problems is that you can check your answers, and I really encourage you to do this. We can just put our values back into the equations and make sure that they agree. So let's look at the first equation. 4 lots of 3.5, well, 4 times 3.5 is 14, plus 3 lots of 2 is 6, equals 20. Correct. Let's check the second equation, and it's kind of magical when it works. 2 lots of 3.5 is 7, 5 lots of 2 is 10, and 7 plus 10 is 17. And when you put your values back in and check that they satisfy the equations, if they do, it's gold-plated. You can be absolutely sure that you've got the right answers. Now, I have to say, I'm going to be slightly critical here of the Scottish examination system. You would not get full marks if you had solved the problem as I have here, because they insist that the students, as a final sort of step, write in words sort of the answer to the narrative. So they have to write in words, it takes 2 hours to sow a field of barley, it takes 3.5 hours to sow a field of potatoes. Actually, other way around. I think that's, to be honest, a little bit silly, because we've defined what these variables are, we've solved for them, and in any professional application of maths, you have at this point solved the problem, and everything else is window dressing. That's just my opinion. But if you are in the Scottish system, do remember that you have to write out a couple of sentences at the end to just put into words the answers that you've found. Right, in the second tutorial on this topic, I'm going to do 2 examples a bit more swiftly than this one. One is a formal example that connects back to the topic of straight lines, and the other is an example that's taking place in a microbiology lab. So I'll see you then.